Okay, today we're going to be going over our 5.2 notes, which is all about functions. Let me zoom in here, make sure we've got everything keyed up. Okay, let's see. So first of all, let's make sure we get our name and class period on the notes. And this is my video copy. This is actually just one page of notes today. You're welcome. Okay, so a relation. Let's start there. A relation is any set of points, just like you might think that your relations are your family. There are different points in your family group or on your family tree. A relation is any set of points. So an example might be -1, 2, 0, 0, 0, 5, and 3, -7. So this is a relation because we have literally just a set of points. Okay, let's move on to the next. I know that was the trickiest thing you've ever heard, isn't it? So on to our next one, talking about domain. Domain is going to be all x values. So when we're talking about the domain, let's think about up here of this relation. We have a -1 is our x value, a 0, a 0, a 3. Okay, so to get my domain of this relation up here, I could say x equals -1, 0, 0, 3. So that's my domain for this relation up here. Now, something else we can think of is a relation can also be shown as a graph. So this graph right here where we've got just some points on it, that is a good example of what this graph might look like. It's not exactly the same points, but it's an idea. It's just going to look like kind of a scattering of dots. However, we could also have relations that are lines. And we know from lines that they go on forever and ever in both directions. So the domain of this line, meaning how the possible x values and the possible the possible x values going this way and the possible x values going that way, there's not anything that's bounding it on either end. There's nothing that's stopping it. So here we have like really concrete numbers, but we know that this goes on forever and ever. So domain also sometimes can be written as -infinity is less than or equal to x, because that is our value that we're working with for domain, which is less than or equal to infinity. So those are two examples of what domain might look like. And the last thing to keep in mind with domain when we're thinking about our x values and we're thinking about our x-axis is we're thinking about how far left and how far right can our graph go. We're only thinking about it side to side. Okay, so the next term we're going to talk about is range. So we talked about domain is all x values. Well, range is all y values. So let's look at our relation we had up here. So our y values are going to be 2, 0, 5, and -7. So if I wanted to write the range of that, instead of x equals, now it's going to be y equals 2, 0, 5, and -7. So there's a domain of something that looks like that. We also, though, can have a domain when we're looking at a graph. So for example, this graph right here, again, just like there's nothing binding it on either side from continuing to go on forever and ever left or continuing to go on forever and ever right, there's also nothing, if this line keeps going up, these y values are just going to keep going up and up, and these y values are just going to keep going down and down. So just like When it was x, we can say that negative infinity is less than or equal to, this time it's y because we're talking about range, which is less than or equal to infinity. Okay. Sometimes these that have the infinity are called ARN, for all real numbers. You might see either one of them. Okay. And just like with domain, we talked about everything going left to right. So how far can it go to the left? How far can it go to the right? For the range, we're talking about how far up can it go and how far down can it go. So up and down. And I know it can be kind of tricky to keep in mind which one is domain, which one is range. One of the ways that I remember it is that when I say the word range, it sounds kind of like it has a y in it, so like a little bit of a y. So range. Also, this G kind of looks like a Y, where it's one of those letters that kind of has some above. Oh, I didn't show you at all. It's one of those letters that has some kind of above the line, and then it goes below that line, if you remember back to handwriting days. So that looks kind of like a Y. So that's how I remember it. It's not the best way, but it does work. Okay, last but not least for new terms is function. A function is a relation with no repeating x values. So it's kind of like a square is a type of rectangle. A function is a type of relation. So up here, let's look at our x values. We have -1, 0, 0, 3. Oh, we do have some repeating x values. Our zeros repeat. So this is not a function. This relation up here is not a function because we have some repeating x values. Okay. So now let's write a relation that is a function. So the only thing is we can't have any repeating x values. So let's do -5, 1, -2, 1, 0, 0, and 5, -5. Now I intentionally had some repeating numbers in here to kind of trick us up, but we're going to look at it. Remember, I told you this one is not a function. So it's really important that when we're looking to see if it's a function or not, we look at the x values. So I'm going to go in and underline just my x values in each of these points. So I have -5, -2, 0, and 5. None of these repeat. There's not another x value that's -5. There's another 5, and then there's a -5y value, but there's not another x value that's -5. -2, 0. There's another 0, but it's a y value, and then 5. So this is a function because there are no repeating x values. Okay. So we have a couple of little tests that we can remember to help identify if things are functions or not. First off, we have the relationship rule. So this is a little bit of one of those things that's a piece of life advice as well as some algebra knowledge. So here when we're talking about, let's think about if you're in a relationship with somebody. If you start repeating with your ex, if you start dating your ex again, I think we all know that there's a reason that they are an ex, an ex-boyfriend, ex-girlfriend, whatever. If you start repeating with them, dating them again, that relationship won't function. So if you repeat exes, it won't function. So it's not a function. So just like if we think about relationships, not a good idea to repeat with your exes, right? Because it won't function. If we have repeating x values, it's not a function. And this helps when we're looking at ordered pairs, tables, and mappings. These are ordered pairs up here. Points is another thing that we call them. But we also will deal with a table here in a little bit. So next up is the other thing that we can think about to help us identify if something is a function or not is the vertical line test. This helps when you're looking at a graph. So I'm going to draw two quick graphs here. Dun, dun, dun. Okay. And okay. One of these passes the vertical line test and one fails it. So with a vertical line test, you draw a vertical line anywhere on the graph that you want. So I drew a vertical line here. It only crosses my graph one time. So, and in fact, there's no place I can draw a vertical line on this entire graph where it's going to cross more than once. So the most it ever does is it crosses once. So this passes. This is a pass. The vertical line only crosses one time. So this is a function. Okay. If we were to write out all the points that were on this line, we actually proved it here. There's only one point right here that's going to have 1 as an x value. So my x value doesn't repeat. There's not another y that's going to have an x of 1. So this is a function because we have no repeating x's and it does pass our function test. Now, I think we can all figure out that this one, womp womp, fails the function test. But let's think about why. So this does fail. And it's because the vertical line crosses, and I'm going to use a little inequality here, more than, so the number of times that the vertical line crosses is more than 1. Okay? In fact, it crosses twice. So this point right here, it doesn't really matter what the y is because I know that my x is 1. And this point right here, I also have an x of 1. So I have repeating x's, and we know that that will not function. So that is not a function. Okay. Go ahead and get caught up on that page, and then meet me on over on the next page. Okay, so we are going to decide if these are functions or not. Remember I told you we would talk about tables? We're talking about tables. So this is a table, and one of my students pointed out that I did have a typo on here. This should be y, not x. Okay, so this is a table. And what this is each row you can think of as a point. So like we have -4, 8, we have -2, 4, and so on and so forth, right? But all I'm really looking at to decide if something is a function is I'm looking to see if it has repeating x's. Okay? So I'm just looking at this column. I have -4, -2, 0, 2, +2, not -2, and then 4. I see no repeats in that x column, so this is a function. I'm not repeating with my x, so it could function. Okay. Next up, make sure I'm on the right color. We all know that that's very important. Okay, next up, we have example 2. This is ordered pairs. And again, I know that I am looking purely at my x values when I'm trying to decide if something is a function or not. So I look at my 1, 2, 3, 2, 1. Ruh-roh. Do I have any repeats? Oh, 1, 1 and 1, 5. Those both have 1 as an x value. Uh-oh. And honestly, I also have 2, 2 and 2, 4. Those both have 2 as an x value. So is this a function? No, because I have repeating x values. That is not a function. Last but not least, let's practice with the vertical line test. So, you know, these markers aren't supposed to bleed through. I don't know what's going on here. I think they're getting a little cheap with the paper. Okay, so example 3. Remember our vertical line test. If the vertical line only crosses one time, then it is a function. If it crosses more than one time, then it is not a function. So I'm going to draw a vertical line. Uh-oh. How many times does it cross? 2 times. That is more than 1. 2 is more than 1. So that is not a function. No, that is not a function. Okay. This one we have, I know it's kind of hard to see, but we have just separate points. It's not actually a line. But there is no point on this graph where I could draw a vertical line that would cross through more than one of those points. I'll draw a couple in here to show you. Okay. So this, I do not have any repeating x values, so it passes the vertical line test because my vertical line only crosses through one point. So it is a function. Next up on this line that we were talking about earlier, we can just toss a vertical line anywhere in there. And I know it's only going to cross one time, so that is a function. And last but not least, I can draw a vertical line on this one, and it's still only going to cross one time, so that also is a function. So the only one that doesn't pass the function test is this circle. Okay, go ahead and get caught up on that, and then we're going to go on to evaluating functions and talking about function notation. Okay, so this part that we're going to talk about is function notation. All that means is writing things as if they're functions. So some things that we need to be aware of here are that whenever we see something that looks like this right here, where it says f parentheses x parentheses, this is actually said f of x. Or you might hear it, it might be called function f. This one, I bet you can't figure it out. It's g of x. Okay? So f of x, g of x. Really, you can see any letter in this position. Most likely, though, you're going to see f. You might see g or h also. Okay? So what this is doing is it's telling us that we have a function, and we need, when we get x, we need, if our input is x, then it's going to give us, we need to square x, and that will tell us what the output is. So there's actually a tricky way you can do this in DESMOS that almost feels like computer programming. And I'm going to show you guys how to do it. So I know that for all of these, f of x is x squared, and g of x is 2x plus 1. So I can go into DESMOS and teach DESMOS, almost like computer programming, just like on a very small scale. I can teach DESMOS what f of x is. So I can say, okay, DESMOS, f of x equals x squared. Okay, to get this x squared, or to get that exponent, you can either use shift 6, which gives you an arrow up, or you can use your happy little keyboard over here, you would use a squared. Okay. So now I need to tell it what g of x is. G of x, not c, x. G of x is 2x plus 1. Okay, so now I have told DESMOS that while I am doing this, I have two functions, f of x and g of x. If I give you an f of x, I want you to take my input, take whatever I give you, whatever I put in here, and I want you to square. If I say g, then I want you to take whatever I put in these parentheses, multiply it by 2, add 1. Okay, so let's see if we can figure out some of these. Let's see what f of negative 1 is. F of negative 1. Oh my goodness, it's 1. Let's see if we can figure out g of, okay, g of 2. Oh my goodness, it's 5. Do you guys see how this works? It's actually really easy. And this part looks so tricky, doesn't it? You're like, Miss, I have no idea. F of negative 1 plus g of 2. So f of negative 1 plus g of 2. You'll notice I'm typing it exactly as I see, and it's working because, remember, way up here at the top, I told it, hey, if I tell you f, this is what you do. If I tell you g, this is what you do. Okay? So f of negative 1 plus g of 2 equals 6. And we can do a little bit of a sanity check on this one. I know that f of negative 1 is 1, right? And I know that g of 2 is 5. Well, what's 1 plus 5? Fascinating. Oh my goodness. Oh my goodness. Let's see if we can figure out the next row. And we don't have to change anything because we're still using these basic equations. This is just like when we did substitution, but we're learning how to do substitution just a lot faster. Okay, so we have f of 5. F of 5 is 25. Uh-oh, g of 3/7. Whew, glad I'm not having to do this math. Remember, when you see a fraction, it's division. There we go. Okay, now it gave me a decimal, and I know that Miss McNabb is going to flip her lid if I give her a decimal. So I'm going to click my fraction button, and I'm going to get 13/7. Okay. So now I know I need to do f of 5 minus, remember, see, we changed our operation here. So f of 5 minus g of 3/7. Okay. Oh, and I talked it out, but I didn't type any of it. F of 5, y'all, it's been a day, minus g of 3/7. There we go. Oh, more decimals. Oh, phew, thank goodness for DESMOS, because it tells me that it is 162/7. I also know that I could do 25 minus 13/7. Let's double check ourselves to make sure we got that all right. 25 minus 13 divided by 7 equals, oh my goodness. Oh my goodness, we got it right. Done. Okay, last but not least, let's find f of 10. Remember, I don't have to change anything because I'm still using these same basic equations up here, or the basic functions. Okay, so f of 10 is, would help if she was typing, f of 10 is 100. G of negative 7 is negative 13. Okay, Uh-oh, she changed it up here. Miss McNabb may have been a little bit tired when she was doing this and accidentally made a mistake and put an extra 0. But that's okay because we can do it and we can still get it right, and it is not tricky at all. So f of 100 times, you can either do shift 8 or you can do your times over here, times g of negative 7. Okay, and that is negative 130,000. Oops. Okay. So as a quick reminder, this is kind of the tricky part. We see f of x when it looks like that, f of negative 1, f of 5, f of 10. G of x when it looks like that, g of 2, g of 3/7, g of negative 7. And then we can even add those too, and it's not super tricky at all. The only thing we have to make sure we do is we have to start off by teaching DESMOS what f of x is and what g of x is. Okay? That is it for today. I hope y'all have a great day. Thank you so much.